Dear colleagues and friends of innovation, I wish you warmly welcome to Neste's Technology Center in Kilpilahti, Finland. My name is Lars-Peter Lindfors and I am the Senior Vice President of Innovation. With me today I have Mia Laamanen, Head of Feedstock Research, and Vice President of R&D Petri Lehmus. Please note that the streaming will be recorded. Firstly, I want to congratulate Professor Balasubramanian and Professor Kleinerman for receiving the Millennium Prize. Congratulations on behalf of all Neste employees. What a groundbreaking innovation indeed. We are now in the Technology Center of Neste, where we have more than 1,000 great employees working with innovation. This is the R&D, technology and engineering hub of our company. The place where we have the whole value chain of capabilities that are needed for innovation coming together. Here several innovations have seen the light of day, such as the groundbreaking NextBTL technology. We at Neste are on a continuous journey exploring new fields of sustainable solutions for an improved quality of life. We are broadening our renewable and circular solutions, looking at ways to continuously develop and grow our businesses. For the longer term perspective, we are developing business innovation platforms, looking at, for instance, renewable hydrogen, power to liquids, municipal solid waste, lignocellulosics and algae. At the same time, we are also in parallel making sure that we stay competitive in the shorter term in the existing businesses by continuously broadening the feedstock base in wastes and residues and also turning those wastes into sustainable high-quality drop-in solutions for various markets. These are indeed exciting times to work with innovation. Our aim is to be a global leader in renewable and circular solutions. This is why our Feedstock Research Lab is at the very core of our strategy. And here I would like to hand over to Mia to present some of the promising feedstock types that we have investigated and further developed. So Mia, please.
Thank you, Lars-Peter. I will start with an example from our current pool of renewable feedstocks. So this is used cooking oil. Used cooking oils are oils and fats that have been used to cook food in the industry, in restaurants, in households. And for food hygiene reasons, they are no longer fit for human consumption, so that's why they are considered waste. And waste and residues, such as this used cooking oil here, account for 83% of our current renewable feedstock pool. And by 2025, we want to increase that share. So by then, we want it to be full 100%. Then my next example here is waste plastic. And when this waste plastic is liquefied, it can actually replace traditional crude oil as a more sustainable alternative. And we focus on post-consumer waste plastic that cannot be mechanically recycled. So for example, multi-layer packaging materials, colored materials and such. And we hit a key milestone last year. We did a processing run at our refinery with liquefied waste plastic. And by 2030, we want to process over 1 million tons of liquefied waste plastics annually. So we have key targets there. And then my final example is one of our future options. So this is algae oil. Microalgae can grow basically wherever there is water and sunlight, and they can produce high oil contents or high oil yields. And when the oil is removed from the biomass, it contains high energy density, which makes it an excellent raw material for biofuels production. We at Neste have explored and developed the use of algae for over 15 years now. And now with all of these feedstocks, it's good to know that they all contain impurities. So typically they're not suitable for upgrading as such. The impurities may interfere, for example, with the next processing step or even with the final product quality, so they have to be removed. And now in this lab where we are at the moment, we develop technologies to remove these impurities. And once removed, then these feedstocks, a range of feedstocks, can be converted into high quality, either renewable or recycled products. And now we have sent a larger sample of this algae oil for further upgrading, and I will now hand it over to Joni Kunnas so we see what happens to it next. So we'll see you soon.
Hello everyone, I'm Joni Kunnas, Head of R&D in Catalyst and Refining. We're in front of Neste Technology Center testing building. Let's have a look how we're gonna change this new feedstock into products.
Hey Joni,
Hello.
what do you have here?
Well, it's a new renewable feedstock. I was just coming to discuss with you how we're gonna turn this feed into products.
Yeah, looks interesting. Well, we have different scales of reactors from batch to pilot to convert this feedstock to renewable products with catalytic upgrading. So I was thinking we can use bench scale reactor in this case.
That sounds good, yeah?
Yeah, are there any safety related considerations with this feedstock?
I think the procedures, protocols we have should work pretty fine for this one as we've done before, so with the renewable feedstocks.
Okay, I will take this for the testing.
Okay, thank you very much.
Thank you. Hello Mirka.
Hello, Yasin.
Here we have a sample for a new feedstock.
Oh, nice.
Can you start preparations for the test run?
Of course. I'll start preparing the test run.
The test run preparations are started with detailed risk assessment to enable safe operation. To start with the catalytic upgrading, the reactor is packed with the desired catalyst. Reactor is attached to the testing rig and pressure testing is performed. Feed for the processing is prepared by making a blend with required ratio. Feed is added to the feed tank and the upgrading is commenced at defined process control parameters such as temperature and pressure. The test equipment is followed regularly via automated process controls and corrective actions are taken in case of any deviations. Product is collected and analyzed for different properties.
Hi, Yasin. The product is ready and I have a small sample here if you want to check that out.
Looks bright and clear. You can proceed with the distillation. I will give you the cut points.
Yes, thank you.
Finally, the product is distilled with defined temperature cut points into different product fractions for further in-depth analysis.
Hey Joni, do you have a moment?
Hello Yasin, come on in.
We have now processed the feedstock into this renewable product. Here is a sample.
Wow, looks really great.
We have the batch ready for you.
Okay, that's really great. So let's take it forward for Teemu's team for the field testing.
Thank you.
Thank you very much, Yasin.
Thanks, Joni, for the fuel. My name is Teemu Sarjovaara. I work here as a head of R&D for products and applications. Next, I'm going to guide you through Neste's product testing process in our engine laboratory. Please follow me. As a true technology forerunner, we have responsibility to ensure the operability of our products. And although we are here today talking about feedstock research, we must remember that changes in feedstock will always influence product properties. What does operability of our product mean in practice? It means that, for example, diesel fuel needs to operate in different vehicles, both on hot summer days and on freezing winter nights. The testing of the new fuel starts with blending the fuels, since in real life, fuels are mixtures of different components and additives. After that, we take fuels to the various test rigs to see the performance related to the specific properties like lubricity and filterability. In the next phase, the fuel is taken to engine and vehicle dynamometer tests where the engine or vehicle is running controlled condition over a specific cycle. For instance, we test diesel fuels with vehicles in chassis dynamometer in cold ambient conditions to ensure cold operability. Field testing, where the fuels are tested on road in real-life conditions for 15,000 to 100,000 kilometers, is a crucial part of our product testing. Each car is measured on chassis dynamometer before and after the field test to see the possible performance effect of the fuels during the test campaign. The field testing is the final part of fuel's test journey in our laboratory, and it aims to prove the fuel's operability on road conditions so that our customers can rely on our products.
Okay, thank you, Teemu, and welcome back to the Feedstock laboratory. This is the laboratory where we have examined thousands of samples from all over the world and sent them then, first purified them and then sent them into the research pipeline for further upgrading and application testing. You have now had a possibility to look a bit behind the curtains, and there's certainly some questions in the chat, and we will start to go through them. So, yeah, there seems to be one question from the audience to Lars Peter. So hydrogen is a very hot topic in Europe at the moment. So what's Neste's vision for the hydrogen economy in the future, and will hydrogen replace other feedstocks?
Well, I think hydrogen is, of course, a very hot topic today, and we are also at Neste working with hydrogen. For us, it has two merits to work with hydrogen per se. First, we can, with time, reduce the carbon footprint in hydrogen production, moving from fossil to renewable sources of electricity. And secondly, it also has an opportunity, together with carbon dioxide, to become power to liquids. And also hydrogen per se can be sold on the market. So it has a lot of opportunities, but there are also very many challenges still that we must overcome. So there is room for breakthrough innovation, for instance, in the electrolyzers and their technology is still to come, and also safety around hydrogen. But it's a very exciting topic indeed. And we are working now in both Rotterdam with a pilot plant erection there, and then we have the Porvoo plant where we are looking now for potential for producing renewable hydrogen.
Okay, so the first step is in a way to use it in the refineries, and then longer term in a way use it together with carbon dioxide to produce liquid synthetic fuels, for example.
It's like a two-step rocket somehow, yes.
Right. Then there's another question, and that's what will be the most used renewable raw material in the future?
Yes, of course, it's a very vast question, and personally I think that in order to combat climate change, we need all solutions to work. So we need to look at this from a very broad perspective. So I think all kind of scalable bio and circular economy wastes will be needed together with the electrification and other sources to combat the climate change. So I think that there is a vast variety of feedstocks that we will be using.
So many to achieve the impact, yeah.
Yes.
That's right. Then there's a question about are all these raw materials suitable for aviation fuel? And maybe I can myself answer that. So our focus currently is more on this hydrotreated esters and fatty acids, so-called HEFA feedstock. But of course, the aviation is a big opportunity. There's a need for liquid fuels, so of course we need to work on other feedstock also into that pool. But it's a regulatory process which it's very carefully regulated, of course, understandable. But we are working on different feedstock, but not all of these are yet in a way accepted for aviation fuel. But it can be. We can work on it. And then there's also a question: what are the easiest and what are the most difficult to use? Maybe that goes for me as in the research lab.
Yeah, maybe just very shortly. In a way, easiest. You could consider that the oils and fats based are easiest because we already have existing technology to use them. But of course, we are always pushing boundaries towards more and more challenging feedstocks, and so we are always developing technology further. So in that sense, today there are no more, in a way, easy feedstocks available, I think.
So work to be done also in future.
Exactly,
Yes.
exactly.
Okay, I think we have used our session time. Maybe Lars Peter, if you want to close up.
Yes, so thank you, Petri, thank you, Mia, for joining me here, and thank you everyone who has been attending this virtual tour of Neste Technology Center. Wishing you all the best for the future, and let's innovate together. Thank you, and bye-bye.